Hello guys, welcome back to my YouTube channel. So as I told you guys, I'm creating a playlist about data structures and algorithm and subtopics of that main topic. So as the first video in this playlist, I'm going to demonstrate you guys about excuse me, I'm going to demonstrate you guys about array stacks. So let's get started. Okay, let's start with the first question, the first cue. What is an array stack? So array stack is an array that contains a stack. You know, those two words combined, an array and a stack. So let's first talk about the stack part. Excuse me. So a stack, what is a stack? What is the general imagination of a stack that you hear the word stack? So you can imagine it's like a stack of plates. You know, we all know what it looks like. You know, a stack of plates. So a stack is just like that. It's a LIFO type of stack. So last in, first out. In a stack, always last in, first out. Because as I told you earlier, let's take that example, a stack of plates. So in a stack of plates, if you want to remove a plate, what's the first plate that removes from the stack? Is it the last plate or a middle plate or the first, the on top plate? It always be the top plate, you know. So if you try to get a plate from the bottom or in the middle, the stack will fall and crash all the plates. So the most excuse me, the most practical way to remove a plate from the top. And if you put a new plate, if you enter a new plate into the stack, into the existing stack, you can add that plate on top of the existing top plate. You know, you can't put the new plate, the new element in the middle. You know, you can't do that. That's a stack. That's a basic you know practical imagination of a stack. There are three main operations in array stacks. Those are pop, push, and peek. What is push means? Push means pushing an element into an existing array stack. So just as the word says push, it means entering a new element into the existing array stack. So as we all know, in a stack you can only interact with the top element. So if you push a new element, you put that new element on top of the existing top element. Okay, so what is pop? Pop is just like that. Pop means popping out the last element in the stack. So that main principle follows to this operation too. The last element of the stack is the interactive element. So if you want to pop a element, the last element of that stack is going to pop, you know. So what is peek? Peek means it's like the word says, peeking. Peeking means like, you know, peek. So if you want to peek the top element, the last entered element, you can use the peek operation. It allows you to see the last element in that stack. Okay, why we use array stacks? Let's talk about it. So there is some major advantages as it's very effective, it's very accurate, and because it has a fixed size, it's very efficient. It won't use much space, and fast access, because it has every element have its own index, and those elements are stored in a sequential way. So when you retrieve those data back, you can retrieve those data, access it fast and accurately, very efficient. So also low overhead compared to linked lists. And what are the disadvantages? There are some disadvantages as well. As I told you earlier, this array stacks have fixed size. So if you declared the size at the beginning, you can't adjust it afterwards. You can't extend it or excuse me, reduce or whatever. You can't do it. That's a big cap. And also there is a stack overflow hazard. So if you are using array stacks, you have to always keep in mind what is the capacity. I mean, if it's full, you have to maintain it, or otherwise it will exceed capacity and overflow. That's a big disaster. So less flexibility compared to dynamic stacks. So dynamic stacks are way more flexible. You can do whatever you want to do in dynamic stacks, because it called dynamic stack because it is dynamic. You can adjust and flex more than this array stack. So that are the advantages and disadvantages. So let's move to the next Q. When to use an array stack. So as you can see, expression evaluation, it means passing mathematical and logical expressions via stacks. Because we are using stacks, array stacks, it has indexes and sequential, those qualities helps to mathematical and logical expressions. So we can use array stacks to it. And undo mechanisms, because of the sequential part. Sequential means one after another, so you can undo a certain thing very efficiently and very fast. Also syntax checking, we use array stacks to check syntaxes, verifying balanced parentheses and code blocks in compilers. So as the last one, backtracking algorithms, so exploring paths in puzzles or searches efficiently, because it use memory very efficiently. We can use that quality and implement into backtracking and backtracking algorithms and stuff. So if you run this code, if you study this code, you can clearly see what we were talking about earlier. Stack grows upwards as item push, as it says, shrinks on pop. If you pop, the array shrinks. If you push, the array grows upwards. Array indexes represent stack positions efficiently. Yes, because array has an index, every element have index, and it positions efficiently. Okay, let's talk about how to implement an array stack. So first, initiate array and pointer. It means create an array and set top pointer to -1. Why? Why -1? So if you put 0, your first element will be indexed as 1. We won't do that. We want to be our first element indexed as 0. The zeroth indexed is the first index that we push into the stack. So if we want that to happen, we have to create an top pointer and declare it as -1. So the first element that you push into the stack will be 0th index. And second, push operation. Increment top and store new element at top index. Push operations, as we talked earlier, simply push operation. 3. Pop operation. Return element at top and decrement top pointer. It decrements the top pointer. Top pointer means the highest, the last added index. So it decrements it because we popped out one, and return the element. Okay, so the fourth one, peak operation. Peak operation means, as we talked earlier also, looking at if we want to identify what is the element on top, we can use peak operation. And handle errors. Check for overflow and underflow before you push or pop. That is a crucial point, So you have to check before you push or pop whether it's empty or full, or otherwise it will overflow, and that's not a thing to happen. Okay, so in the next slide, common mistakes and how to avoid those mistakes. Ignoring overflow. So if you ignore the overflowing cap, the limitation of overflowing, that's a disaster. You have to keep your eye on the size of the array, size of the stack, and every time before you push an object into the push an element into the stack, you have to check whether it's full. That will save your stack. So underflow errors. Underflow error means ensure stack is not empty before you pop out elements. As the first one, ignoring overflow, underflowing errors is important as well. So incorrect pointer updates. Update the top index precisely after each operation. You have to do that, otherwise it won't, if it's not indexed well, those advantages we talked earlier are pointless. So that is the main, a big advantage of array stacks. So another one is fixed size limitations. Consider dynamic resizing if stack size varies greatly. This array stack use fixed size, so that limitation is always there. You can't undo it, or you can't resize it in the middle of the code. So you have to declare the size earlier. I recommend you guys to put an headroom to what you declare to the stack, so it will help. Okay guys, so we came to an end to this video. So this is the first YouTube Studio experience for me. So if I did any inconvenient things or some inconvenience, I'm really sorry. So see you guys in the next video. Bye bye.